besides graphing, I guess, to solving a system of equations is called substitution. And it's pretty straightforward. You just substitute in for one of the variables, and we'll show that here in a second. So here's our following ways that we're going to solve systems. Graphing, we just did that the other day with intersections, right? We say that's where the two lines intersect. So I can solve any system that has two variables, but if the variables are x and y, now they're on a coordinate plane, right? So I can do it by graphing for the intersection. Today we're going to do substitution, and then we're going to get into elimination. And some of the elimination are pretty straightforward. Other ones we actually have to multiply, and it gets a little more challenging. And depending on how the equations are written or how they're given to us, one's going to work better than the other. But today all we're going to do is substitution, and we'll see, when it's easy to do substitution and when it gets more difficult. So for example here, I have two equations with two variables. So my first equation, y equals negative 4x plus 12. Second equation, 2x plus y equals 2. And two variables, x and y. And that's a system. So to solve a system, we're going to use substitution here. So really all I want to do is get one of the equations equal to either x or y. So get one equation either as y equals or x equals. And in this case, I already got that here, don't I? I have this equation right here. Y equals negative 4x plus 12. So I'm saying that y equals this. I can put that into any equation where there's a y. I can plug in negative 4x plus 12 anywhere there's a y, because I'm saying that's what y is. So I can actually plug it in for this y down here, because I'm saying that's what y is. I can plug it in there. So what I want to do is rewrite this second equation, 2x plus y, but instead of writing y, I'm plugging in that negative 4x plus 12. And it might be a good idea. I always like to just put it in parentheses right off the bat. Sometimes I don't need to put it in parentheses, but it just helps me remember, just in case we have to distribute or something like that. So I'm plugging that in for y. So we just replace that with our negative 4x plus 12. And now we simplify the left side. Well, I don't really need my parentheses because I have a plus sign out front. So it looks like here 2x and a negative 4x gives me negative 2x plus 12 equals 2. And then we solve for x. So subtract 12, and I'm left with negative 2x equals negative 10. Divide by negative 2, and x equals positive 5. Is that my answer, though? No, I want to solve the system. Well, to solve the system, our solutions are written as an ordered pair, aren't they? So far, I know that my x is 5. But how do I find the y? How do I know what y is going to be? Well, plug it back in. So I can plug in that 5 to either spot. I can either plug the 5 into the second equation or to the first equation. And I'm just going to take the first equation just because y is by itself. I think that's easier for me. So negative 4 times 5, because I said that's what x is, plus 12. And then when I solve, y equals negative 20 plus 12. So y equals negative 8. So now I plug that in, negative 8. There's my solution. All your answers should be an ordered pair. So if I plugged in 5, negative 8 into each of these equations, it would work out. And if I would graph both of these equations, they would intersect at what point? 5, negative 8. Okay, that's their point of intersection. That's the solution to that system. So we're just substituting in. Well, if I look at this next one, it's not. I don't see a y equals or an x equals. I don't see one of those. I can get one though, can't I? And in this case, which one is easier to get by itself? Well, this bottom one, I have a 3 connected with the x and the 5 connected with the y, so I don't want to work with that one. This guy's probably a little bit easier, isn't it? I can get the x by itself. Because all I have to do is just add my 2y to the other side. So now I have x equals, and I'll just put the 2y first. I like putting the variables first. 2y and a negative 3. Positive 2y and a negative 3. So I just replaced this equation with this guy. I just switched the spots. I got x by itself. Because now I'm saying that's what x is. So I can plug that in for x into my other equation by substituting it in. Substitution. So let's go ahead and do that. So now I have 3 times x, and I said x is 2y minus 3. So I like to put that in parentheses. plus 5y equals 24. So I just rewrote that second equation and plugged in whatever I said x was there. So now I can go ahead and distribute. That's why I put it in parentheses so I can see that. So I got 6y minus 9. 3 times negative 3 is a minus 9, negative 9. Plus 5y equals 24. And now we simplify and solve. So 6y plus 5y is 11y minus 9 equals 24. So we add our 9 over, and then we divide by 11. And it looks like we end up with 3. So y equals 3. That's part of my solution. I know that y is 3. But I got to plug it back in. And remember, it doesn't matter where you plug it back in at. Okay, I could go back to my original equations. I could plug into the new equation I made. So I'm going to go up here. I'm going to plug it in right there. Since I got one equation equal to x. So I'm saying x equals 2 times 3. That's what I solved y for. Minus 3. So x equals 6 minus 3, which is 3. So there is my solution, the point 33. That would work for both equations. Just solve the system. So substitute in. Okay, same thing here. Just be careful. And in this case, now I'm not looking at the first equation. I already have this second equation equal to y. So I can substitute in for y into the first equation, right? So it could be from the first into the second or second into the first, whatever you want. So I'm saying y equals this, so I'm going to plug that in for y. Here's where you got to be careful. When I plug that in, so I'm going to rewrite this first equation. 2x, it's minus y. So minus, this is where the parentheses are important. Minus 2x minus 3 equals 8. Because what happens, this is really an imaginary negative 1 out front, so I got to distribute a negative 1 when I simplify. So just be careful sometimes. Don't work too fast. So 2x, negative 1 times 2x, or distribute that negative, is a negative 2x. And then negative 1 times negative 3 is a positive 3 equals 8. Well, 2x minus 2x, that's gone, isn't it? Huh, what's going to happen here? So I have 3 equals 8. Does that make any sense? No, it doesn't make any sense. So what do you think about this one? No solution. No solution. Huh. Well, what was that going back to our graphing the other day? If I think about this, what if I got this second equation into a slope-intercept form like this first one? If I add, or if I subtracted 2x over right away, I'd have negative y equals negative 2x plus 8, and then divide by basically a negative 1. So what happens is y equals, I just changed all the signs, 2x minus 8. Right? I basically just changed the signs. And if I look at their slopes, don't they have the same slope here? So they're parallel lines. Okay, one's going through negative 3, one's going through negative 8 on the y-intercept. So really, they're looking like this. They're parallel. That's why there's no solution. So if I don't get x or y equal to something and it doesn't make sense, no solution. If it does make sense, then they're the exact same line, and that's, you know, infinitely many. But these ones would end up being parallel, so no solution. And last thing, when I get something like this is where we're not going to use substitution in the future because elimination is going to work out better. But in this case, let's just get used to doing substitution. We should still be able to do this just applying our algebra. So now I can really pick anything. I can pick anything. I could solve for, get x by itself up here, get y by itself, get y by itself, get x by itself. You just got to pick one. None of them, not one's better than the other or anything like that. I'll just deal with this first one. I'm going to get x by itself. So I'll do that. I'll do that down here. 4x minus 3y equals 1. I'm going to replace that guy. So to get x by itself, I got to move the y over. And I'm left with 4x equals 3y plus 1. And then we divide by 4. Got to divide the whole side by 4. Remember, following your rules of algebra. So this is really, remember, 3/4 y. So I'm just dividing, I pull out the y. Plus 1/4. See, I get a bunch of fractions. That's why we don't like doing that as much. So there's my new system. Now, I'm going to rewrite this up top. I'm just going to replace the one I just changed. So I have x equals 3/4 y plus 1/4. And I'm going to rewrite this one next to it. So 6y minus 8x equals -2. Just replace that one. So I'm going to substitute in for x. So I'm plugging this guy into x right there. So I have 6y, rewrite that second equation, minus 8. And now I'm saying that's what x equals, so I plug it in. So 3/4 y plus 1/4 equals -2. Boy, I say it's going to get sloppy. A lot of work here. So I bring down my 6y, -8 times 3/4. And if you have a calculator, save yourself some time. Otherwise, my 8 and the 4 cross cancel. So I'm left with a -2, so -6y. Plus, distribute -8 times 1/4. Well, 1/4 of 8 is 2, and a negative times a positive is a negative. I don't want a plus sign there. So -2. So 1/4 of -8 is -2 equals -2. And 6y minus 6y. Oh boy, these cancel, don't they? That's gone. Well, -2 equals -2. If I look at that, that makes sense, doesn't it? So this is infinitely many. Infinitely many solutions. It's not all real numbers, because not any solution works, but there's an infinitely many amount of points on those lines. Because if I would actually graph these lines, if I would have went back to my original equations and got them in slope-intercept form, they'd be the exact same equation. Okay, they'd be the exact same equation. So if it makes sense, infinitely many. All right, just some work on substitution in our systems of equations.